Hiya, in this video we're going to look at ions and ionic formula. As you've known from the last video, atoms are more stable with a full outer shell. And they get this by reacting with each other, exchanging their electrons to become more stable. Take this example of a sodium atom with electron configuration 281 and a chlorine atom with electron configuration 287. The sodium is more stable when it loses that one electron, and it does this by giving it to the chlorine atom, which is more stable when it gains the one electron. This produces a chloride anion with electron configuration 288 with an extra electron, and a sodium cation with electron configuration 28, having lost that one electron. You can see the electron that is moved in red, moving from the sodium atom on the left to the chloride on the right. Let's have a look at the general pattern of gaining and losing electrons, reflecting back to our metals and our non-metals on the left and right. The metals on the left-hand side have 1, 2 or 3 valence electrons, so they tend to lose these valence electrons to form positive ions, such as magnesium up here in group 2 with 2 valence electrons. And this forms the Mg2+ ion. Try and see those patterns. On the right hand side, the non-metals have 5, 6 or 7 valence electrons, so they gain electrons to form negative ions. For example, let's have a look at the fluorine atom here, which has 7 valence electrons and gains 1 to form F-. At times we need to explain this in more detail. Let's take a look at magnesium. Magnesium has atomic number 12, which means it has 12 protons and an electron configuration of 282. As it has 12 positive protons and 12 negative electrons, it's electrically neutral, but it doesn't have a full outer shell, so it's unstable. To get stable, it loses 2 electrons to get this full outer shell and becomes Mg2+. Why is it Mg2+? It still has 12 positive protons, still atomic number 12. However, it now has 10 negative electrons in the arrangement 2-8. With 2 extra protons, 2 electrons, it is now charged +2, and it is now stable. Let's look at Mg2+ again. If an atom forms a positive ion by losing electrons, the electrons have to go somewhere. It's not magic. For every positive ion, there has to be a negative ion, somewhere for the electrons to go. For example, F-. Here are 2 big general ideas. There must be the same number of electrons lost as electrons gained. And because of this, there must be the same number of positive and negative charges. This doesn't look like it's the case with Mg2+ and F-. So let's take a further look at this on the next slide. Writing ionic formula. Mg2+ and F-. There's 2 positives but only 1 negative. To make these equal, we need another fluoride ion. This gives us 2 negative charges and 2 positive charges. When we write the formula for this compound, we write MgF2. We write the positive ion first, and there's only 1 Mg. That gives us 2 positive charges. We write the negative ion second, and the small 2 tells us we have 2 Fs, giving us our 2 negatives, and overall this is a neutral compound with the same number of positive and negative charges. A little bit more complicated is these things called ion groups. You do get a list of these in level 1 NCEA without the names, unfortunately. These are groups of elements that must stay together. The charge is the bit up the top. Any number down the bottom must stay as it is, it's part of its name. And these are the ones you use bracket for if you need more than one of them. Let's take as an example iron 2 hydrogen carbonate. There's actually only two parts to this word, the iron and the hydrogen carbonate. And I've chosen hydrogen carbonate because it's the one that's not listed in the table above. The 2 in iron 2 means 2+. So looking in your table of ions, you choose Fe2+. Hydrogen carbonate is in the -1 column, so it is HCO3 1-. There's one negative charge here and two positive charges, so we need 2 hydrogen carbonates for every 1 Fe2+ to balance those charges and make a neutral compound. Here's where we need to use the brackets, because otherwise we'll have HCO32, and that just doesn't make sense. Now let's have a practice. Go and get your table of ions and use it to practice writing formula for the following compounds. Pause the video now and then come back when you've had a go yourself. Lithium chloride. Both ions have one positive and one negative charge, so we only need one of each of them to make a neutral compound. With magnesium oxide, both have 2 charges, 2 positive for Mg and 2 negative for O. So again, we only need one of each to make a neutral compound. However, with sodium sulfide, Na has 1 positive charge and S has 2 negatives. So we need 2 Nas to balance the 2 negative charges of 1 S. With ammonium sulfate, it's a little bit trickier. We've got 2 ion groups. NH4 has 1 positive charge and SO42- has 2 negatives. So again, we need 2 ammoniums to get 2 positive charges to balance out the 2 negatives in the sulfate. This time, however, because it's an ion group, we need brackets. And lastly, Ca and OH. Calcium has 2 positive charges and hydroxide only has 1 negative. So we need 2 hydroxides. This one needs brackets because O and H are different elements, so we do need to show this with brackets. Lastly, we're just going to have a look at explaining this in a lot of detail, and this time by using electron transfer. Again, using sodium sulfide. So here we have Na+ and S2-. So with 1 positive charge, we can see that 1 sodium has lost 1 electron. And that electron has gone to the sulfur, which wants to gain. However, sulfur needs to gain 2, so we need another sodium to give away another electron so that sulfur can get its 2. So from 2 sodium ions, sulfur gets its 2 electrons, giving us our formula of Na2S. In this way, we can see that the total number of electrons lost by 2 sodiums is equal to the total number of electrons gained by 1 sulfur. And in our final slide, we're going to again explain the ionic formula, but this time in terms of the charges instead of the electron transfer. We're going to keep with sodium sulfide for our example. So again, we've got Na+ and S2-. We have 1 positive charge from 1 sodium and 2 negative charges from 1 sulfur. So we need another sodium ion to get our 2 positive charges, giving us 2 sodiums to 1 sulfur. This gives us a total number of positive charges as 2 from 2 sodiums and a total number of negative charges as 2 from 1 sulfur, making a neutral compound.